Good morning. Welcome to class 9 physics. We are continuing with our second chapter, motion in one dimension. And now we are coming to the graphical representation, numericals based on that. As you can see, question number 1 shows a graph. The graph shows the motion of a body. Calculate the velocity of the body from A to B. You can spot A here and B. Velocity of the body from B to C. And the velocity of the body from B to D. B to D. Now, when they give you a question like this, first of all, look at the axis. This is displacement against time graph. So, if I want velocity, remember velocity we learnt in the earlier video that our velocity is going to be delta y upon delta x. That is the slope of the graph when it is displacement against time. And so that will give us displacement upon time, because you will see that delta y is giving you from here to here, it's giving you the displacement, and from here to here it's giving you time. You want it from A to B, the velocity, so your AB you'll have to take the slope of. So delta y becomes 5 meters and delta x is from here to here, that is 2 seconds. So we'll substitute the values and we will say it is 5 meter upon 2 second, and that is 2.5 meter per second, and that is our answer 1. Now let us look at the second part. In our second part, we are asked find the velocity of the body from B to C. Again, from B to C, this will be our velocity 1. Now we come to velocity 2, which is from B to C. You will again do delta y upon delta x, but in this case you will see that your delta y is 5 meter minus 5 meter, that is 0. So you will have 0 upon t, which is equal to 0 meter per second, and that becomes our answer 2. You could also say that since the displacement remains constant with respect to time, the body is at rest during that time. Now let us come to the third part. In the third part, again we are asked the average velocity from B to D. Now for average velocity, let us write that. Average velocity is the total displacement upon total time. So let us look at how much is our displacement. Now at B the displacement was 5 meter, and the displacement at D, it has come back over here. You will see from 5 meter it has come back to displacement 0, and so you will see that the average velocity is going to be displacement, that is 5 meter, but the total time that is taken from B to C is from 2 up to here. After 2, this is 1 second, 2, 3, 4, 5, 6, 7. So you have 5 meters upon 7 seconds. Let's double check. From B, 1, 2, 3, 4, 5, 6, 7. So it is correct, 7 seconds, and that will give you average velocity 0.7749. Remain 1, so 7 ones. 7, remain 3, 7 fours, 28. So 3 decimal places should be enough for us, and this is our answer 3. Now we come to our second question. In the second question, A and B are two cyclists whose motion is shown in the adjacent graph. So you can see distance, displacement is on y-axis and time is on x-axis. From 0, this line goes, that is the motion of cyclist B, and from this 5 you can see the motion of A. The first subpart says how much distance is cyclist A ahead of B. When we started with a stopwatch at 0 time, B is at 0 displacement and A is already 5 meter mark. And so A is ahead of B by how many meters? It is 5 meters. So this is your answer 1. Second part says what is the velocity of cyclist A. Now for velocity, the velocity of A, I'll simply call it as VA. We will have to take the graph of cyclist A and we will have to do delta y by delta x, which is delta s upon delta t. Now you can take any one of the markings from here. We want to find velocity of A. This is graph of A. So we can take this as our delta y and this as our delta x. Now how much is this? This is your delta s, which is 10 minus 5, which is 5. Let us write it over here. 10 minus 5 meter upon, how much is our time here from here to here? It is 1 second. So we will say it is 1 second. And so you get 5 meters upon 1 second, and velocity therefore of A is 5 meter per second. So we have 5 meter per second, and that is our answer 2. What is the velocity of cyclist B? Cyclist B, again we have to look at the graph, and we will now take, for B, let us take from here to here, that will be your delta y, and from here to here this will be our delta x. So we are taking this triangle like so. So again we will say velocity of B will be delta y upon delta x, which will be your displacement upon time. We will see displacement is from 0 to 10. So that is 10 meter upon, from here to here it is our delta x, which is 1 second, and so it becomes 10 meter per second. And that is our answer 3. In the next part we are looking at number 4. In how much time does cyclist B catch up with cyclist A? As you can see, cyclist B starts from here and then he catches up with A at this point. In how much time does he catch up? From this point you come perpendicular distance down, so that is your 1 second. So in 1 second. And here we will say again 1 second, and that is our answer 4. Let us look at the next part. How much distance did cyclist B have to travel to catch up with cyclist A? B had to travel up to here. From this point you have to drop the perpendicular. So B had to travel up to 10 meters. So our fifth answer is 10 meter. This you will see directly from the graph. So that was this question. Let us come to the last question of the graphical representation numericals. You can see the graph, and this time the graph is velocity against time. Now do you remember velocity against time? What will the slope give us? The slope will give us delta y upon delta x, that will be delta v upon t, and delta v becomes what? Change in velocity upon time becomes rate of change of velocity. So the slope gives you acceleration, and also the area that is between the graph and the x-axis, that will give you v into t, and that will be the displacement. So let us look at this. So from the adjacent graph, find the distance traveled in the first 5 seconds. Now from first 5 seconds we have from here to here, so we have to use AB. So we will write using AB. You will have the displacement will be equal to the area of triangle BEA, and that will be half base into height. The base is 5 seconds multiplied by the height, which is 10 meter per second. So 2 will go here 5 times, and that will give us 5 is 25. So we have 25 unit wise seconds will get cancelled, and 25 meters is what we will get as our first displacement. Now we come to the distance travelled in the next 10 seconds. Now next 10 seconds is from 5 to 15, and that gives us area here. So this will be equal to the area of rectangle, or it's a square, yes, of BCFE. That will be 10 into 10, 10 seconds. Let me just put the units also. 10 meter per second, that is from here to here, multiplied by from here to here, this is 10 seconds, and that will give us 100 meters. Now we come to the distance travelled in the last 10 seconds. Last 10 seconds will be the area of triangle CFD. So we will say that will be area triangle CFD. That will be half base into height, will be equal to half base is FD, which is 10 seconds, and the height is from here to here, that is BE, that is 10 meter per second, and you will see this is equal to 50 meter. Now the total distance it has travelled is, from total distance has become 25 plus 100 plus 50 meter. That is 175 meter. Now let us come to the acceleration. When it comes to the acceleration, where is the velocity increasing? From A to B. So the acceleration is going to be slope of AB. Now slope of AB, again we have delta y upon delta x. Delta y will be this, that is the velocity. It is going to be 10 meter per second, and upon delta x, that is going to be here this much, that is your 5 seconds. And that comes out to be 2 meter per second, so that is 2 meter per second square. And that is our answer 5. This was our answer 4. This was our answer 3. This was our answer 2. And this was our answer 1. Let us come to the retardation. Now retardation is where the velocity decreases. You can see for BC the velocity is constant, that means 0 acceleration, and for C, from C to D, you will see velocity is decreasing. So again we will take retardation. Retardation is going to be delta V upon delta T. Delta V upon delta T, because we have taken delta Y upon delta X. So that will give us from, that is 10 meter per second. From 10 up to here means this one will be our delta Y upon, how much is the time from C to D? See, if you drop the perpendicular from here to here, it is 10 seconds. And so it becomes 10 ones, and then you'll have 1 meter per second square. And that is our answer 6. Now supposing they had to ask you the acceleration. Just note this. The acceleration during CD. Then it would have been final velocity. I'll do V minus U upon T. This way also I can do. Or that would become 0 minus 10 upon the time period would be the same 10, and that would be minus 10 upon 10, and that would give us minus 1 meter per second square. And understand that if it is minus 1 meter per second square acceleration, then that negative acceleration becomes retardation. So retardation will be a positive quantity, but if it was asked as an acceleration, it would have been a negative quantity. So I hope you are able to understand how graphically you can find the values of different quantities that are asked in the numericals. I hope you are confident now. Thank you for watching.